Have you ever stopped to think about time? It is perhaps the most familiar yet most mysterious force in our lives. We all live by its rules. We wake up in the morning, we go through our day, we go to sleep at night. Each moment follows the last in a straight, unbroken line. It is a one-way street, a journey that only ever moves in a single direction. We are born, we grow older, and we remember our past. We never remember our future. This is the fundamental rhythm of our existence. A constant beat that has governed every life that has ever been lived on this planet. This relentless march of time is something we take for granted. An egg falls from a table and shatters on the floor. We see the cause, the fall, and then the effect. The broken shell. We never see the pieces of a shattered egg magically reassemble themselves and leap back onto the table. This is what physicists call the arrow of time. It points from the past, through the present, and into the future. It is the reason why order tends to become disorder. But what if this was not the only way? What if the universe did not have to follow this rule? Science often begins with a simple, powerful question. What if? What if time is not a one-way street after all? What if there is another road, one that leads in the opposite direction? Imagine a universe where the clock ticks backwards, a place where the arrow of time points not to the future, but back into the past. It is a mind-bending idea, one that sounds like it belongs in the realm of science fiction. Yet, it is a possibility that some of the greatest minds in physics have seriously considered. This strange idea forces us to question everything we think we know. If time could run backwards, what would that even look like? How would life exist in such a place? Let's try to picture it. A world where everything we know is flipped on its head. Would people be born from their graves and grow younger each day? Would they remember the future and be mystified by the past? These are not just idle questions. They push at the very limits of our knowledge about the cosmos. Exploring this possibility takes us on a journey to the heart of physics. Physicists have a name for this hypothetical place. They sometimes call it a negative universe or an anti-universe. The idea is that our universe might not be alone. At the moment of the Big Bang, perhaps two universes were created, not just one. Our universe, where time moves forward from that initial explosion, and a mirror universe, an exact reflection of ours, where time moves backward from that same point. It is a stunning and elegant idea. It suggests a perfect symmetry to the cosmos, a balance between a world moving into the future and another moving into the past. This mirror world would be a fascinating place. It would be made not of matter, but of antimatter. Antimatter is real. We have created it in our laboratories. It is just like regular matter, but with an opposite electrical charge. An anti-electron, called a positron, has a positive charge. An antiproton has a negative charge. When matter and antimatter meet, they annihilate each other in a burst of energy. This is the most efficient energy conversion process known to science. The secret to the arrow of time seems to lie in a powerful and famous concept from physics, the second law of thermodynamics. It states that in any isolated system, things tend to move from a state of order to a state of disorder. Scientists have a special word for this disorder, entropy. The second law says that the total entropy, or disorder, of the universe is always increasing. This increase in disorder is what gives time its direction. The universe started in a very special, highly ordered, low-entropy state at the Big Bang. Ever since then, it has been unwinding, becoming more and more chaotic. While the second law of thermodynamics provides a compelling explanation for the arrow of time, it also deepens the mystery. If the universe is constantly moving towards a state of greater disorder, then that must mean it started in a state of incredible order. The initial conditions of our universe appear to have been finely tuned. Out of all the possible ways the universe could have started, it began in a state of exceptionally low entropy. Scientists have no definitive explanation for why this was the case. It is a feature of our universe that we observe, but we do not yet have a fundamental theory that tells us why it had to be this way. Let's venture deeper into the world of physics. Here, we find a very strange and beautiful idea. Most of the fundamental laws of nature do not seem to care about the direction of time. This is a concept known as time reversal symmetry. Imagine watching a video of a planet orbiting the sun. If you play the video backwards, the planet gracefully retraces its path. The laws of gravity work just as well in reverse. Nothing looks out of place or impossible. This symmetry is not just for gravity. It applies to electromagnetism too. The laws governing how electric and magnetic fields behave are also time-symmetric. This is the conflict that lies at the heart of modern physics. On one hand, we have the fundamental laws that are perfectly happy with time going either way. On the other hand, we have the second law of thermodynamics, which insists that time must only go one way. It's like having a car that is perfectly designed to drive both forwards and backwards, but for some reason, it is stuck in the forward gear. They started to wonder if our universe is only half of the picture. Perhaps the symmetry of the laws of physics is not broken, but is instead expressed on a much grander scale. Physics has a very powerful, overarching principle known as CPT symmetry. This is considered one of the most fundamental symmetries in nature. The letters stand for charge, parity, and time. Think of it like a cosmic mirror. If you take any event in our universe, film it, and then perform these three operations, swap all particles for their antiparticles, flip the image horizontally like a mirror, and play the film backwards, the resulting scene should look perfectly natural. This principle is incredibly robust. So far, no experiment has ever shown a violation of CPT symmetry. It seems to be a fundamental rule that the universe must obey, a deep truth about how reality is structured. If CPT symmetry holds true for the entire cosmos, then it suggests that our universe cannot exist by itself. To satisfy the CPT rule, it must have a partner. This partner would be a universe dominated by antimatter, with its spatial properties mirrored, and where time runs backward relative to ours. The two universes together would form a perfectly symmetrical whole. This is a beautiful and compelling idea. It suggests that the Big Bang was not just an explosion, but a moment of perfect symmetry creation. Our universe and its anti-universe moving away from each other in opposite directions of time, like two runners starting a race back to back. From our perspective, their clock is ticking backwards. From their perspective, our clock is ticking backwards. Let's step through the looking glass. Let's try to imagine a typical day for someone living in this mirror universe, where time flows backwards. For them, the day wouldn't begin with the gentle pull of consciousness, but with its gradual fading. Their first act might be to sit down at the dinner table. Before them, a plate of dirty dishes and leftover scraps would be waiting. As they sit, the food would miraculously reassemble itself from their stomach onto the plate, piece by piece, becoming whole and hot once more. They would sit at their desk and spend hours taking completed documents and breaking them down into their constituent parts, ending with a blank page. The goal of their work would be to deconstruct, to return things to their original, unused state. In this reverse world, the fundamental law of cause and effect would be flipped on its head. For us, a cause precedes its effect. We strike a match, and then it lights. In the mirror universe, the effect would precede the cause. Let's consider a conversation. In the reverse world, a conversation would start with the final conclusions and work backwards to the initial greetings. Two people would meet, knowing the outcome of their discussion. An act of creation for us would be an act of restoration for them. A sculptor wouldn't start with a block of marble and chip away to reveal a statue. Instead, they would begin with a finished statue and carefully add marble dust and chips back onto it. Perhaps the most mind-bending aspect of life in a reverse-time universe would be the nature of consciousness and memory. For us, our memory is a library of the past. We can recall events that have already happened, experiences that have shaped us. For a person in the mirror universe, this would be completely swapped. They would have no memory of their past at all. Yesterday would be an impenetrable fog, a time they have not yet reached in their backward journey. Their memory would in fact be of the future. Imagine waking up each morning with a clear and detailed memory of everything that is about to happen during your day. You would know exactly who you are going to meet, what conversations you will have, and what tasks you will perform. This structure of memory would redefine learning and knowledge. A student would not go to a lecture to learn something new. They would start the class already knowing the subject perfectly. The lecture would be a process of the professor methodically unteaching them. Knowledge would not be acquired, it would be shed. The wisest person in their society would not be the one who knows the most, but the one who has forgotten the most, having journeyed furthest back from the great repository of future knowledge. In our universe, the arrow of time is driven by the second law of thermodynamics, the relentless increase of entropy or disorder. But for an observer in the mirror universe, this fundamental law would appear to operate in reverse. From their perspective, the universe would be on a constant journey towards greater order. This principle would govern everyday phenomena. A puddle of water on the pavement would gather itself up from disparate droplets and leap into the sky to join a cloud. A building that had collapsed in an earthquake would see its bricks and beams fly back into place. For a physicist in this universe, the second law of thermodynamics would be stated in reverse. The entropy of the universe is always decreasing. This would be their fundamental arrow of time. Despite all these bizarre and counterintuitive descriptions, it is crucial to understand one final vital point. For the people living in this reverse time universe, nothing would feel strange at all. Their reality would be entirely self-consistent and logical to them. They would not feel like they are moving backwards. From their perspective, they are moving forwards, from their past to their future. Their past is what we call the future, and their future is what we call the past. Our scientific laws and their scientific laws would be mathematically identical. The equations of gravity, electromagnetism, and quantum mechanics would be the same. The only difference would be the boundary conditions and the direction in which time and entropy flow. Let's use an analogy to compare our universe with its hypothetical twin. Imagine two vast libraries standing back to back. Our universe is one library. In it, we start with a single, perfectly written book, the highly ordered state of the Big Bang. Over time, the pages of this book are torn out, scattered, and copied imperfectly. The library becomes filled with countless new books, but they are all variations, fragments, and disordered versions of the original. The reverse time universe is the other library. For an observer inside, their arrow of time points the other way. They watch as scattered pages slowly and magically find each other, forming coherent sentences, then paragraphs, then entire books. Our universe is a story of divergence and diversification, of one becoming many. Their universe is a story of convergence and unification, of many becoming one. It's a cosmic tale told in two opposite directions. We see the universe as a process of aging and decay because we are on the side where entropy increases. An observer in the mirror universe would see the opposite. They would perceive the universe as a place of constant renewal and assembly. Comparing our universe to its hypothetical twin forces us to confront the ultimate question: why? Why is our universe the way it is? Why do we have this specific arrow of time? The idea of a mirror universe offers a compelling answer. This comparison also highlights how much of our reality is defined by our perspective. We think of cause and effect, the flow of time from past to future, and the increase of disorder as absolute truths. The mirror universe concept suggests they are not. It means that to truly understand the cosmos, we may need to step outside of our own limited directional experience of time and see the whole symmetrical picture. We have journeyed to the very edge of what science can imagine. We have explored the strange, beautiful, and deeply puzzling idea of a universe that runs in reverse. A cosmic twin to our own, made of antimatter, where time flows not towards the future, but back into the past. So could these negative universes actually exist? The honest answer is that we simply do not know. The concept remains highly speculative, a magnificent piece of theoretical physics that currently lies beyond our ability to test. However, the lack of direct evidence does not mean the idea has no value. Far from it. This kind of thinking is what pushes science forward. It forces us to confront the assumptions we make about our own reality. By imagining a world where cause and effect are reversed, where the future is remembered and the past is a mystery, we gain a much deeper appreciation for the specific conditions that make our universe what it is. It highlights the profound questions that we are still trying to answer. Scientists continue to explore these ideas at the frontiers of cosmology and particle physics. They search for tiny violations of symmetries in particle accelerator experiments, looking for clues about the early universe. While the idea of a mirror universe is a long shot, it is a possibility born from the fundamental rules of physics as we understand them. It represents one of the most profound possibilities about the ultimate nature of reality. And so, we are left looking up at the night sky, just as our ancestors did, filled with a sense of wonder. But our questions have changed. We no longer just ask what the stars are, but why the river of time flows only one way. We wonder if beyond our sight, on the other side of the beginning, a mirror image of our cosmos is living out its own story in reverse. We may never know for sure. But the act of asking the question, of pushing the boundaries of our imagination, is what defines our species. The truth about time remains the greatest unanswered question, the final frontier in our quest to understand our place in the cosmos. The biggest difference between our universe and a negative one is simply the direction of the story, and we are only witnesses to one of the two possible tellings.